How to Master 3D Printing, From Design to Creation, CosmoTech Chronicles. Hey everyone, welcome back to CosmoTech Chronicles, your go-to channel for all matters pertaining to technology and innovation. Today, we have an exciting topic to delve into: the incredible world of 3D printing. If you've ever wondered about the limitless possibilities of this technology, you're in for a treat. In this video, we'll explore the capabilities of 3D printing and showcase some fascinating examples of what you can create. So, let's not waste any time and dive right in. Understanding the basics. Before we get into the exciting projects, let's start with the basics. What is 3D printing, and how does it work? Well, in simple terms, 3D printing is the process of creating three-dimensional objects from a digital model. It's like printing a physical object layer by layer. Here, we have a basic 3D printer. It uses a spool of filament, which is heated and extruded layer by layer to create the object. The printer reads the design from a computer and precisely builds the model. Types of 3D printers. There are various types of 3D printers available, such as fused deposition modeling, FDM, stereolithography, SLA, and selective laser sintering, SLS. Each has its own unique capabilities and materials they can work with. Let's briefly touch on these types and when you might choose one over the other. Fused deposition modeling, FDM. How it works: FDM is the most common and accessible 3D printing technology. It uses a heated nozzle to melt and extrude a thermoplastic filament layer by layer to build an object. Applications. FDM is versatile and used in various applications, including prototyping, hobbyist projects, and manufacturing functional parts. Stereolithography, SLA. How it works: SLA uses a liquid resin that is cured by a UV laser, solidifying one layer at a time. This process creates highly detailed and smooth objects. Applications. SLA is preferred for creating intricate and high-resolution prototypes, dental models, jewelry, and collectibles. Selective laser sintering, SLS. How it works: SLS utilizes a laser to selectively fuse powdered materials, often polymers or metals, layer by layer. It does not require support structures, as infused powder supports the object. Applications. SLS is employed in manufacturing end-use parts, complex geometries, and functional prototypes, especially when using materials like nylon or metal. Materials and their applications. Now that we know the types of printers, let's talk about materials. 3D printers can work with a wide range of materials, including plastics, metals, and even bioinks for medical applications. The choice of material depends on the specific project and its requirements. We'll explore some common materials and their applications in this video. PLA, polylactic acid. Application. PLA is one of the most popular materials for 3D printing, suitable for a wide range of applications. It's often used for prototypes, consumer products, toys, and decorative items. It's biodegradable and easy to work with. ABS, acrylonitrile butadiene styrene. Application. ABS is known for its strength and durability. It's commonly used in automotive parts, electronic housings, and functional prototypes. ABS has a higher melting point than PLA, making it more heat-resistant. PETG, polyethylene terephthalate glycol. Application. PETG is a versatile material with excellent layer adhesion and toughness. It's used for food containers, medical devices, and mechanical parts that require durability and impact resistance. Nylon. Application. Nylon is valued for its strength, flexibility, and durability. It's used in functional prototypes, gears, bearings, and applications where high wear resistance is needed. TPU, thermoplastic polyurethane. Application. TPU is a flexible and rubber-like material. It's commonly used for making phone cases, shoe soles, custom grips, and wearable devices due to its elasticity and soft texture. PC, polycarbonate. Application: PC is known for its high impact resistance and optical clarity. It's used in applications such as automotive components, protective shields, and lenses. Metal powders: stainless steel, titanium, aluminum. Application: metal 3D printing with materials like stainless steel, titanium, and aluminum is crucial in aerospace, healthcare, implants, and automotive industries for producing high-strength, complex metal parts. Resin: various types. Application: resin materials such as standard, flexible, and dental resins are commonly used in SLA and DLP 3D printers. They are ideal for highly detailed and intricate models, including dental prosthetics, jewelry, and figurines. Creative projects: here's the fun part. Let's dive into some creative projects to showcase the true capabilities of 3D printing. We'll look at examples from various fields like art, medicine, automotive, and more. From creating intricate jewelry to custom prosthetics and even functional car parts, 3D printing has revolutionized how we make things. Here are some creative projects that showcase the true capabilities of 3D printing. Customized jewelry and accessories. Architectural models. Cosplay props. Functional prosthetics. Educational models. Art sculptures. Dental implants. Scale models. Custom phone cases. Artificial organs. Fashion and wearable tech. Automotive prototyping. Mechanical parts. Miniatures and board game pieces. Home decor. Designing for 3D printing. If you want to harness the power of 3D printing, you need to know how to design for it. Whether you're a beginner or an experienced designer, there's something for everyone in this video. Designing for 3D printing is a crucial aspect of harnessing the full potential of this technology. Here's a brief overview of the key considerations. Understanding 3D printing processes. Design software options. Design guidelines and support structures. Wall thickness and orientation. Tolerance and clearances. Layer height and infills. Overhangs and bridging. Model integrity. Material selection. Iterative design. Post-processing steps. Future possibilities. As we wrap up, let's talk about the future of 3D printing. With advancements in technology, we're pushing the boundaries of what's possible. From printing organs for transplants to constructing entire houses, the future looks incredibly promising. The possibilities are only limited by our imagination. And there you have it, folks, a glimpse into the amazing world of 3D printing. Whether you're a hobbyist, a professional, or just someone curious about the technology, I hope this video has inspired you to explore the capabilities of 3D printing further. If you enjoyed this video, please don't forget to give it a thumbs up and subscribe to CosmoTech Chronicles for more exciting tech content. If you have any questions or ideas for future videos, please leave them in the comments below. Until next time, keep exploring and innovating with technology. Thanks for watching.